So today is the last part of these using the exponential properties that we've been talking about. You guys are going to have a quiz on this next week on Tuesday. So after today, we'll just be reviewing Thursday, Friday, and Monday, and then quiz on Tuesday. So today we're going to talk about what to do when we have different bases in our expressions that we're trying to simplify, because up until this point we've only been dealing with the same base, so all of the expressions that we've been trying to simplify have all had the same base. So when we have multiple bases, there's a couple extra properties that we need to know. First is the power of a monomial. This is when you have a expression that is multiple bases, so like a number, an x to some power, a y to some power, all raised to a power, we'll say 7. And so every number and every variable is its own thing. So remember, this 3 has an implied power of 1 there. And so this exponent that's on the outside of the parentheses here will have to go to every single exponent inside those parentheses. So we would use our power rule for the y, power rule for the x, and power rule for the number. So really we would have like 3 to the first to the 7, x to the n. You don't have to write out this part when you're doing it. I'm just kind of showing you what's going on. So that exponent goes to everything, even the number. So we would end up with 3 to the 7th, x to the n times 7, and y to the m times 7. So you use power rule for each variable and number in the parentheses. Okay, so it's important to remember that numbers are their own thing. They're not like that 3 is not attached to that x term. It's its own entity with its own exponent that we have to deal with. Okay, so when we are simplifying monomials with different bases, so like different bases meaning we have a 3, an x, and a y, all the properties that we've learned, like the power or the product property and the quotient property, those can only be used when we have terms that have the same base. And so one other thing we need to remember too when we're simplifying monomials is if we have the division of a monomial, so with different variables raised to a power, that power also goes to every single thing inside the parentheses. So whether it be multiplied in the parentheses or divided in the parentheses, any exponent on the outside goes to every single variable and every single number inside those parentheses. You use the power rule for everything. Okay, so when we're simplifying, remember you can only use the product and quotient rule with terms with the same base. So that means like x's are all going to be together, y's are all going to be together. You can't use the product rule for an x and a y term because they have different bases. Okay, and then when we're simplifying, we're just going to do one thing at a time. Don't try to do it all at once. Until you have one of each base, one term of each base. And just like yesterday when we're simplifying, we don't want any negative exponents in our final answer. So that'd be the very last thing that you do is move those terms that have to be moved if they have negative exponents. Okay, so if we look at example 1a here, we want to simplify. If we look inside the parentheses first, we can still start from the inside and work our way out. Inside these parentheses, though, we don't have any common bases. We have a 2 and an x. That's as simplified in there as we can get. And inside these parentheses, we have a y and an x. Again, they're not the same base, so we can't do anything there. So now we can move outside of the parentheses. We have this exponent here that we have to deal with before we can do anything else with that y and x in there. So since we have two variables inside the parentheses, remember they both have that implied exponent of 1. The 2 also has an implied exponent of 1. Use our power rule with both variables in there. So the 3 is going to go to the x and the y. So we'll end up with 2 to the first x squared, and then we'll have y to the third, because 1 times 3 is 3, and x to the third, because 1 times 3 is 3. Okay, so that's using the power rule. Okay, and now we don't have any exponents outside of the parentheses anymore. It's just individual for each variable there. So that means the parentheses aren't really important. So if it helps, you can just drop the parentheses so you can see everything is being multiplied together. And now we just need to look for our common bases. So number-wise, we only have 1, 2. So that 2 is just going to stay out in front. There's nothing else we can do there. But with the x's, we have two x terms. We have an x squared, and we have an x to the third. So right now I'm just grouping them together so we can see. And we have one y term. Okay, so then with the two x's, we can use our product rule because they're being multiplied. So we have 2 plus 3, which would be 2 times x to the 5th times y cubed. Okay, and then we only have one of each term. We have one number, we have one x term, and we have one y term. So that means it's as simplified as you can get, and we don't have any negative exponents, so we're good. And again, this rearranging step that I did here, you don't have to do that. Sometimes it can be helpful, though, just to see all the like terms together, or the like bases together, but you don't have to. You can go right from here to here, that's fine. All right, letter B. So right now we just have one monomial inside the parentheses there, all being raised to the third power. So first I want to go through and make sure all of my variables have an exponent. So this 4 has an exponent of 1 because that number is its own thing. And that A has an exponent of 1. And B has its exponent of 4 already there. And so since this 4 times A times B to the 4th is all inside the parentheses being raised to the third power, that exponent, we're going to use the power rule for all three terms, all three bases inside the parentheses. So 4 to the 1 times 3, A to the 1 times 3, and B to the 4 times 3. Okay, so when we have this situation, when we are expanding our the problems that we're doing to have multiple bases, we can now start simplifying or evaluating these numbers here, because sometimes you'll have multiple or different bases raised to powers, but they're all still numbers, and numbers we can multiply together. So in your calculator, you can do 4 to the third power. So remember that would be 4, and then the caret key, which is underneath clear, and then 3, and hit enter. And that should give you, 64 times A to the third and B to the 12th. Okay, numbers like this, when it's a number raised to a power, these are the only things you can evaluate in the calculator. You can't type in a to the third in your calculator and get a number because a is just a variable. We don't know what it is. Question, yeah.
Do you always have to simplify it like that?
It depends. Sometimes if I ask to simplify completely, that is helpful, and especially if we have different bases, like if we had a 2 to some power in there as well, having all the numbers together in just one term is going to make it more simplified. Yep. Okay. Any questions so far? And it's all the same properties, it's just doing it now with different bases, so multiple things at one time. All right, letter C. So remember, all of our properties, the quotient and the product rule, can only be used if we have the same base. So we have this m in the numerator and an m in the denominator. So we can use our quotient rule for those. We can't combine it with this n term because m is a different base than n. So we use our quotient rule, we will subtract. So m to the 5. And then we have to subtract no matter what, and we're subtracting a negative 3. Just gotta be careful there. And then with the n term, there's just one term, but it has a power raised to a power, which means we can use our power rule and multiply those exponents. And I've dealt with all the different bases in that original problem, so I can go ahead and do my subtraction and multiplication here. So 5 minus a negative 3, same as saying 5 plus 3, so m to the 8th. And 6 times 2 is 12, so n to the 12. Okay, and again, we know we're done because there's no negative exponents, and we have one term of each base. We have one m term and one n term. All right. Huh? All right, letter D. Letter D, we have a negative now involved. You got to be very, very careful because notice all this stuff is in parentheses. So really this is saying negative 2 in parentheses squared, right? Because this exponent will go to everything. Have to keep the parentheses because the squared was happening outside of the parentheses and the negative 2 is inside. We have to keep that the same. Then we'll have m to the 5 times 2 and n to the 6 times 2. Okay, so the negative 2 in parentheses squared, if you type that in your calculator, exactly as is with the parentheses, close it, and then the caret 2, or you can hit your squared button. To give you a positive 4. And then m to the 10th, 5 times 2, and n to the 6 times 2, it's just 12. Okay, and then we have no negatives, so we're good. We have one number, one m, and one n. So that means we are done. Okay, just a couple more on the back. Any questions so far? These are just going to take practice. Once you do a few and you get more comfortable with it, it'll be pretty easy. All right, so letter A. Again, we don't have any parentheses, we don't have any power rules we have to worry about, but we do have some quotient rules because in our numerator here we have an x and a 5. Those aren't like bases, they are not the same base, so we can't do anything there. Same thing in the denominator, an x and a y. Can't use the product rule because they're different bases, so then we can go to the quotient rule. So we have our x terms and we have our y terms. So we're going to do two different quotient rules here. So we'll have x to the 5 minus 5 and y to the 3 minus 2. And 5 minus 5 is 0, so we'll have x to the 0 and y to the first. And anything to the 0 power is what? 1. 1. So really I don't care about it. This is the same as saying 1 times y to the first. Or if you just want to write y to the first, or if you just want to write y, any 3 of those would be an acceptable answer. For a short answer, if like on the quiz, I don't think we have any multiple choice, but on the test it's going to be multiple choice. So you just have to be okay. It'll probably have just this y as the answer choice. So just make sure you know that these are all the same. But if it's a short answer type of question, any 3 of those would be okay. Okay, let's take a look at letter B. So we do have, in our numerator here, there's nothing we can do. We have an s and a t. Can't combine those yet. In our denominator, we have this s squared times t cubed all raised to the negative first power. So we can use our power rule, bring that negative 1 to both of those. So our numerator is going to be the same. Then our denominator will multiply the exponents. So s to the 2 times negative 1 would be s to the negative 2. And t to the 3 times negative 1 would be t to the negative 3. Okay, so now parentheses are gone, no more power rules, we can't do any product rules, so we're going to go ahead and do our quotient rules because we have an s term in the numerator and an s term in the denominator, and a t term in the numerator and a t term in the denominator. So we have a lot of negative exponents here, so you got to be very careful with your subtraction that you're supposed to be doing with the quotient rule. So we'll have s to the negative 3 minus a negative 2. And then we'll have t to the negative 5 minus a negative 3. So this is a situation where writing out that subtraction on your paper can be helpful because then you can see it. And just type it in your calculator as is instead of trying to do it in your head. So if you do negative 3 minus a negative 2, you should get s to the negative first. And a negative 5 minus a negative 3 should give you t to the negative second. Okay, because again, subtracting a negative is the same as adding. Okay, so we're almost done. We have one of each term. We have only one s and only one t, which is good, but we have negative exponents. So both of these are negative, which means they both want to be in the denominator. So it means we'll have 1 over s to the first and t to the second. And remember, when you move the term, the negative's job is done, so the negative goes away. So you just got to do one step at a time. That one can look a little overwhelming with all of the negatives going on. So just do one thing at a time. Any questions on B? Okay, letter C. So we don't have any parentheses with exponents. We don't have to worry about the power rule. If we look at our numerator, there are no common bases there. They all have different base. We have a number, a y, a w, and an x, so nothing we can combine there. In our denominator, same thing. We have a number, a w, an x, and a y. Nothing we can combine there. So that means we can go to the quotient rule. I'm going to go ahead and rearrange it so that all of my same bases are on top of each other, so it's easier to see. Since all these terms are being multiplied, it doesn't matter what order you put them in. So I have 66. Y to the 9th, w to the 3rd, x to the 6th, over. Then I'll have my number under my number, my y term under my y term, my w term under my w, which has that implied exponent of 1, and my x term under my x term, which again has that implied exponent of 1. Okay, so now we have numbers here. We can evaluate numbers. This is just division. So we can do 66 divided by negative 22 in our calculator. It should give you negative 3. If it gave you a decimal, remember you can hit the math enter button. It'll put it back into a fraction for you, so keep that in mind. This one worked out to be a nice number, but that won't always be the case, but calculator can reduce fractions for you. Okay, and then our y terms. We're using our quotient rule, so it'll be the top exponent minus the bottom exponent. Yep. I'm going to write down all the subtraction first, and then I'll do the subtraction. So then we'll have w to the 3 minus 1, and x to the 6 minus 1. So we just do that subtraction here, and we'll have our negative 3, y to the second, w to the second, and x to the 5th. Okay, and then we have one of each term. We have one number, one y, one w term, one x term, and we don't have any negative exponents. This is a negative number, and that's okay. If the negative is out in front and it's just a negative number or a negative term, that's fine. The only time you have to move stuff is if the negative is in the exponent, not if it's out in front. Letter D. So we have a fraction that's in a parenthesis being raised to the 0 power. Anything raised to the 0 power is what?
1.
Cool, this whole thing is 1. Anything raised to the 0 power, that whole thing is being raised to the 0 power, which means that whole thing is equal to 1. So make sure you're always on the lookout for those 0 exponents. They can make your life a little easier before you do all that simplifying on the inside and then find out 5 minutes later that it was just 1. Okay, and our last one. So working inside, I'm going to just do everything inside the parentheses first and then deal with that exponent on the outside later. So inside our exponent, or inside our parentheses here, we can't do anything in the numerator. They're all different bases, same in our denominator. But we can use our quotient rule with our numbers, our x's, and our y's. So the x and the y in our denominator have that power of 1, so I'm going to write that there. I can divide my numbers. So in your calculator, you can do 2 divided by 4. Make sure you keep it top divided by bottom. And it's going to give you a decimal. Remember, you can hit math, enter, enter, and it will reduce that fraction for you. So when you do 2 divided by 4, math, enter, enter, it should give you 1/2. So that means you'll have a 1 in the numerator and a 2 in the denominator. Or you can just keep your 1/2 out in front. That works too. I'm going to just keep it out in front. Still have my big parentheses here. Okay, then my x's. We have x to the 3 minus 1, which gives us 2. And the y's. Y to the 4 minus 1, which is 3. Okay, so now remember this 1/2 is its own thing. It has an exponent of 1. It's its own number. So when we use our power rule, this -2 exponent is going to go to all 3 of these, the 1/2, the x, and the y. Okay, so we'll have 1/2 to the -2 power. We'll have x, we multiply, so to the -4th, and y to the -6. Okay, so with that 1/2 to the -2, again, that's a number raised to a power, so we can use our calculator. Make sure you type it in with parentheses, though, when you do it. So in your calculator, you would do parentheses, 1 divided by 2, close the parentheses, and then your caret, parentheses -2. And you hit enter. And it should give you 4, hopefully. Okay, so that dealt with the 1/2 to the -2. We're good there. What about my other 2 terms, the x and the y? Are they going to be in the numerator or the denominator? Well, right now they're in the numerator, but they have negative exponents, which means we got to move it, right? So that means this x to the 4th is going to be in our denominator, and the y to the 6th is going to be in the denominator. The 4 stays up because we plugged it in the calculator. We got a normal 4. Exponent's gone. It's just 4. 4 stays up in the numerator, but our 2 negative exponent variables there will move down. All right. You guys have any questions? So make sure with the numbers, whenever you have a number raised to a power, that you're just using your calculator. It's there to help you. You don't have to do negative exponents in your head. Just use your calculator.